3D models are a necessity for many forms of digital media. They are most commonly used in games, but are also frequently used in film, and in more unorthodox careers such as architecture. A well-made 3D model is capable of conveying a realistic or grand structure in the confines of your screen, and can heighten the experience of the various media that feature it. This video presentation hopes to educate you on the production and use of 3D models specific to video games, whilst also showing and analysing various examples from certain titles. So first off, let me explain. The definition of a 3D model is a mathematical representation of a three-dimensional object. Basically, it's a bunch of numbers and code that come together to form a digitally viewed item. These models can come in various different formats such as .fbx, .obj or .stl. They are usually created using some form of modeling software. Some well-known ones are 3ds Max, Mudbox, Blender and Maya. Finally, there are multiple different structures and methods to creating a model in these engines, which I will explain later. First of all, let me show you how these models are built. Starting off, there are vertices or vertex. These are invisible points that can be placed wherever inside these programs. Vertices are then joined together by equally invisible lines named edges. You also can't see these on the actual model unless you create a model with sharp edges where they're clearly visible. When 4 vertices create 4 edges and they all come together, they form a face or polygon. A face is the main visible part of a model. They are one-sided and do not fill in empty space in solid objects, like this cube, which is hollow. The visible section of a face is called a surface normal, and is also the side where textures and shaders are applied. Also, there is an element, which is the whole component that you are currently modifying. All of these components can be manipulated in different ways, which will also affect the other components surrounding it. You can extrude faces and vertices, bridge edges or faces together to create new faces with their own sides and vertices, move any of these components around to wherever you want, and overall just destroy your entire computer in the process. However, models will not be formed from a single vertex. These programs will have basic shapes named primitives that have customizable sizes and detail levels, which can be turned into a modifiable poly referring to a single object. Furthermore, depending on the program you use, other tools may be included that will come in use. In a program such as 3ds Max, you have advanced primitives, compound objects, splines, we'll come back to this, lighting components, 4 viewports with varying modes and perspectives, cameras, and multiple render engines to allow for scenes to be created entirely within 3ds Max. These features of the program help give you maximum overview and control when creating your model. Add on top of this modifiers which have the power to completely change models with a few clicks, and you have most of the tools you'll need to create a model that you so desire. Yeah, that's cool and all, but how do you even start this thing? Ah, I see. Well, there are... Yep, this is its own section. Hey, I didn't write this thing. Throughout your time making models, you may use various different methods to form a model shape depending on its convenience regarding what you want to make. For example, spline modeling is a method which uses a customizable line like you would draw in Photoshop, and using various modifiers to automatically create structure that is shaped by the spline that is drawn. The chafe modifier is excellent at creating circular-based models such as a wine glass by taking part of a cross-section from an object and creating geometry in a circle around a pivot like a compass would. As you would expect by now, this modifier also includes different changeable settings to allow you to choose your preferred outcome from this. On the other hand, the sweep modifier allows you to create a precise shape from a spline by expanding it and adding geometry in a set shape. What makes this modifier special is that you can change the shape of the geometry that is attached to the spline, or even use another spline to further customize the final product. Now, if you were creating a cube-shaped crate, you wouldn't use spline modeling. You could, but why? Why be so inefficient when you could use box modeling? Box modeling takes your standard box primitive and trims it down, adding more and more detail to fit the model you are trying to make. It's a lot like sculpting, not to be confused with the sculpting method which uses the actual sculpt tool that doesn't exist in 3ds Max. Programs such as Mudbox will include this, and this is literally sculpting, as you can see. In addition, there's also extrusion modeling, which relies on a smaller box extruding its faces outwards to grow into what you want. The image-based modeling method requires importing an image into your program and tracing its shape with whatever primitive and method works best for you. Procedural modeling is basically giving the computer a bunch of parameters and shapes and telling it to go wild, creating random models from its algorithm. And finally, 3D scanning takes an already created model from the real world and generates a virtual version through some form of detection device. Overall, you should aim to choose a modeling method that will make full use of its specific advantages over the others. Just don't be stupid, okay? Good. Whew, that took a while, so let's focus on something smaller. In basically all programs that use objects on a 3D plane, you have your standard x, y and z coordinates. X is universally recognized as the length coordinate, moving your object left or right while facing it head on. However, y and z are used in both the height and width coordinate depending on the program. To simplify this predicament, we use the terms y-up and z-up when explaining this coordinate system. Y-up means y controls the height, whereas z-up means z does it instead. Pretty simple? Pretty simple. Remember, make sure you take note of different programs' preferences, or if there's an option to change to keep the measurements and position consistent across whatever programs you interface with. Another coordinate system in place is the option of a world and local gizmo system. The gizmo is the arrow thing shown when selecting an object that usually controls its movement, rotation and scale. The world is capable of stopping time for up to... the world option sets the gizmo's position to control the object relating to the current plane, whereas the local option sets the gizmo to control the object as if its current position is the default plane. To better explain it, look at this. This object is at an angle. When I duplicate it upwards in world mode, the object stays on the same z value relative to the entire scene. Now in local mode, it moves upwards still, but at its current rotation, as if being launched out of a cannon. This system change can help simulate rotation of an object like a fan easier, or allow objects to be moved across a certain angled slope, like this fun slide. Truly breathtaking. Requiring usually 6 players that requires one of the game's DLC to access. You can even collect a hidden chest which awards you with items from this activity that should only be accessible to the small population of players who have the DLC and put the time and effort to complete this activity. As shown by these 2 examples, bad collision could cause various bugs and even game-breaking effects, due to the freedom players have whilst outside of the intended playable area. So make sure your collision is solid, and that you don't work for Bethesda. So now you should have a functioning model that has collision. Only problem is it has no colour or detail. This is where materials, textures and shaders are used to bring the look of your object to life. Textures are usually square bitmap images which will be created in a program such as Photoshop, which will be applied to a material. These can range from the basic colour and pattern that will be clearly shown on the model, to advanced maps that exist to control certain variables. Materials are the main component that is used to bring colour to your models. They are made up of a combination of textures, maps and parameters that can affect how the material reacts to other components such as lighting. Common assets used in a material are diffuse maps, opacity maps, bump/normal maps or scalar values that control the material's roughness, metallicness or specularity. All of these features are included to create a more realistic game environment. Finally, there are shaders. Shaders are advanced algorithms that have the ability to change a model's structure and its material's colour through certain actions in real time. For example, a wave shader might be used to make a pool of water seem more natural by slowly rippling the vertices on the surface of the water's model. In addition, there are lighting shaders in every game engine, which also tends to become the bane of your existence. This is an example of a pixel shader, which changes each individual pixel to replicate how each light source in the game will affect it. And of course, now there's ray tracing. Previous lighting shaders only calculated pixels according to a basic simulation of light, whereas ray tracing uses a more complicated simulation that bounces light rays off objects onto other surfaces, much like it does in reality. This is yet another example of how both hardware and software is evolving over time to provide a more realistic gaming environment. I dare to think of what may be achieved further down the line. That's really all there is to materials and other similar components. Yeah, but my material that I made doesn't work, I mean just look at this! Ah, I see. Well then. Much like how models are constructed, there are different methods in which a material is bound to an object. The shape of how a model applies a material is bound to a UVW or UV map. When mapping, we use UVW to define XYZ as to not make it even more complicated than it already is. UVW maps are 3D and can quickly define how selected polygons handle mapping with a set list of basic primitives. Planar mapping places the material as if the selection is a single 2D surface, while box, cylinder and spherical mapping acts like their respective primitives are selected. These forms of mapping are very quick and convenient, however may not work all of the time. On the other hand, a UV map is a 2D image that will be controlled by a program to apply various faces. There are two main methods of mapping using a UV map, unwrapping and pelt. Unwrapping takes each created face and adds it to a map. In this map, you have to manually define where the seams of the materials start and end, as well as what space within the map will define that poly. You would then use this map as a guideline to create your texture in a program like Photoshop. Pelt mapping is more complicated by taking a 3D shape of a selection and using a series of algorithms and stretch points to automatically flatten the shape into a UV map. This will also be drawn upon later. The benefits of a UV map are that it allows for more control over your mapping and would only require a single material, while a UVW map might require several. However, it will take considerably longer to map using this method. In the end, it doesn't matter which method of mapping you use for your models, if you can apply the material how you envisioned, seams exist where they should be, and no form of ungodly stretching occurs. Before we get to our final topic, I want to talk about the various types of meshes that can be constructed and used in a game. There are three main types of mesh, them being rigid bodies, environmental meshes, and breakable meshes. Rigid bodies are objects that have a completely solid structure. They can be pushed around or immovable, but their shape will never change no matter how much force is applied. Environmental meshes are mainly used for objects that would be placed to form a scene. Unlike rigid bodies, these meshes are changeable through a number of methods, such as over time or on player interaction. Finishing the trio are breakable meshes. To put it simply, these were meant for destruction. By having various breakpoints and combustible polygons, these meshes are capable of splitting into pieces with enough force in a certain direction. Now that I've explained them, let me give some good examples of them. For rigid bodies, just look at just look at a video game. Every video game will feature rigid bodies, otherwise every asset in the game would constantly be in flux. The quality of a rigid body will depend heavily on its material, collision, and the game's physics engine. The multicolored beams you play as in Fall Guys keep their shape even when they're launched by a pole or bump into each other, even though technically they are not rigid because of how they bend. However, it's the humour of seeing them launched everywhere that drives the popularity of such a game. This is also applied to the actual rigid bodies found, such as balls and eggs that you might find. An open world game such as the newly released Genshin Impact has the capabilities of showing off how good environmental meshes can get. Take note of the grass being pushed down by your footsteps, blowing in areas of high wind, and burning and charring when fire is applied and put out. Such small effects can cause a huge impact when creating a stunning environment such as one seen here. If destruction is more your thing, look back at hit classic Superhot. Every holdable item and enemy has the potential to be quite literally shattered. Paired with sound effects, it creates a harsh impact that creates a sense of power for the player. And once you add in the slow motion effects of the game, the overall gameplay of Superhot becomes immensely satisfying to play, watch, and hear. Now before you start creating a model, you should take into consideration the following factors that you will need to constrain your model to. Using these guidelines will have various benefits and avoid specific problems in the future, so let's quickly go through them one by one. Not all of your models will be clearly visible across your entire game world. For this reason, lower detailed versions of your models can be swapped in the further your character is away from it. This will save a lot of rendering power by reducing the number of polygons the game is rendering at any one time. The amount of polygons in a model will determine how detailed of a model it is, and how much power it will take to render. Considering games require constant rendering of frames, usually 60 times a second, it is important to keep your poly count as low as you can while retaining the detail you require. Much like poly count, you will need to consider how long a single render of an object will take. If a game stutters each time a new model is rendered nearby, the game experience would not be very smooth or enjoyable for the player. Remember, every console or PC has a set storage amount. The lower your overall file size of a game, the more accessible it will be to players. Because many games nowadays can be digitally downloaded and receive frequent updates, it is important to make sure people have the capacity to play it. More materials on your models means more maps, textures, and shaders to keep track of. This will increase a project's pathing size as well as the overall size of the game, both of which should preferably be kept low. All engines will have their own methods and programs that will render models in certain ways. In general, you should always make sure the way you create a model and the way an engine will render it don't interfere with each other to save time and probable failure. Do you actually know how to operate the programs you are using? It will be much more efficient if you knew how to use a modeling program, a game engine, and even an image editing program that you are going to work on. Creating models and handling a game engine is not a simple task. For optimal work rate and time efficiency, you should make sure the computer you are using can actually handle what you are creating. And finally, the thing you should worry the least about, as there are a lot of free good software out there, but are the programs you're using good enough to create the standard of game that you want? If not, it may be tricky to create the game that you wish for. So hopefully by now, you have a clear idea of how a model can be created well, and how to do it yourself. If not, you have seriously wasted your time watching this. Remember, 3D models will be a mainstay in the gaming industry especially, and quite possibly forever. Over time, as hardware and software are updated and upgraded, so too will the scale and quality of models. There will always be the need for modelers, material creators, and model optimizers of some form, until artificial intelligence is perfected. However, in the meantime, I hope that people like you will take on the challenge and create ever-improving models for us all. Hey, this is Post-Processing Ethan. As this is rolling, I hope you will enjoy these outtakes of me completely losing grasp of the English language over time, with some music to make it less depressing. These outtakes and sources will all be shown in chronological order. Okay, go! Games, but also frequently used in film and more they are most commonly used in games, but are also frequently used in film and in more unorthodox careers such 3D models specific. These models can come in various different. These models can I'm not even reading. Also, there is an element. However, models will and using various modifiers to automatically. As you would expect by now, this modifier, what makes this modifier special is that you can change the shape of the geometry. That is attached to this. That's my throat got. Box modeling. You want to try what? I'm not reading. Programs such as Modbox, procedural modeling again, and just generates adjust. I never said just. In all basic. There's no basic. X is depending on Make sure you take note of a different Becker relative to the entire Z. See? The object stays on the Z. It is that's the right line. It is an integral part. Complex is great at accurately again. Where bitmap images to change a model's structure. Previous lighting shaners. Hardware and software is evolving. Selected polygons handle macking. These forms of mapping are very On the other hand, there are three main the multicolored beans you play as in Fall Guys. I can't even find where the next line. So considering many games nowadays can be digitally downloaded. In general, you should always make God, this sucked to make.